Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafami bin Mazli. I am from Group 7. So today I will present about minor losses in pipe. So for abstract, beside major losses, minor losses caused by the enlargement or contraction of flow section, pipe diameters and pipe bend shall not be ignored. So for this experiment, we are measuring the head loss in pipes for different water flow rates, pipe diameters and pipe bends. The purpose of the experiment is to study or to identify the effect of different water flow rates, pipe diameters and pipe bends on the value of loss coefficient, which is KL. Hence, we collect a few data according to different flow rates. This experiment is conducted by letting the fluid flow to different type of pipe which have different characteristics such as sudden enlargement, sudden contraction, bends, elbow, 90-degree angle, 45-degree angle, and others. So for this experiment, the result that we obtain for frictional factor, which is from range 0.0222 to 0.262, while for the minor loss coefficient, we get the result is from the low value, which is 0.1221 to high value 0.4579. So for objective is to identify the loss coefficient KL and minor head loss HM in pipe component or fitting for different water flow rates, diameter of pipe and type of pipe bends. Major losses occur, so for introduction, major losses occur due to friction within the pipe, while minor losses occur at a change of section, bend or other interruption. For example, pipe junction, bends, valve, contraction, expansion, and resolver, inlet or outlet. In this experiment, minor losses through a pipe section that has several bends, lesion, and fitting will be measured. In the experiment also, there's 5 different volume of what flow rates are used to calculate the result. The actual value of head losses are recorded. The effect of different water flow rates, pipe diameters and pipe bends on the value of loss coefficient KL are discussed. These minor and major losses in pipe section or pipe system play an important role in the overall effectiveness and safety of system. So that this lab is seek a better understanding about minor losses and physical properties related to each other. So that's all for me. Thank you.
Assalamualaikum and good morning. My name is Haris Imran Hisham. So today I want to present my part, which is theory and methodology. So for theory, the flow in piping system at different flow rates may be required to pass through a variety of fittings, bends, or abrupt changes in area. Additional head losses, called as minor head losses, are accounted primarily as a result of flow separation. By simplifying the Bernoulli equation between 2 points for the horizontal pipe, the pressure loss and total head loss could be determined using below equation. These 5 equations. Next. So the value of loss coefficient associated with minor head loss is strongly dependent on the geometry of the component considered, as well as the fluid properties, include the Reynolds number, and the mathematical function of them can be expressed as follows. The equation 6. So basically, in many practical applications, the Reynolds number is large enough so that the flow through the component is dominated by initial effects, leaving the viscous effects as secondary importance. In a flow which dominated by initial effects, it is usually found that pressure drops and head losses correlate directly with the dynamic pressure. Therefore, the friction factor for very large Reynolds number is fully developed pipe flow is independent of the Reynolds number. The same condition is found to be true for flow through pipe components or fittings. Thus, in most practical cases, the loss coefficient associated with minor head loss for components are a function of geometry only. So in this experiment, the KL value and minor head loss in pipes for different water flow rates, pipe diameters and pipe bends will be determined. So the description related to each of the tested geometrical is as follows. First, sudden expansion or enlargement and sudden contraction. So the loss coefficient associated with minor head loss for sudden expansion or enlargement and contraction in circular ducts or pipes are shown in figure 2. Note that losses for a sudden expansion and enlargement are based on speed of flowing medium at region 1, while for a sudden contraction are based on speed of flowing medium at region 2. So the value of loss coefficient associated with minor head loss for the fluid flows through a sudden expansion or enlargement and contraction can be obtained by considering the continuity using equation 7, momentum equation 8, and energy equation between points 1 and 2 using equation 1. And second one is elbows, pipe bends, and pipe branches. So the value of minor head loss and loss coefficient associated with minor head loss for the flows involving pipe components or fittings such as elbows, pipe bends, and pipe branches could be determined experimentally using the equation 3 and equation 3 to equation 5. So in this figure, it's shown that there are many typical value of loss coefficient associated with minor head loss for many pipe and components. Many pipe components. So for methodology, this is the apparatus that we use to complete this experiment. Next, so for the first step, the inlet valve was fully opened by turning it to clockwise direction of tested pipe, and the inlet valve was being closed for non-tested pipe section. Next, the pump is being turned on, and then outlet valve was slowly opened by turning it to anti-clockwise direction until maximum, which is fully open. And then the inlet flowing pressure H1 and the outlet flowing pressure H2 were identified for the tested pipe section, and the manometer tubes was connected from those H1 and H2 of the tested pipe section to the two tube manometer, which is H1 is inlet and H2 is outlet. And next, the values of H1 and H2 have been recorded at two tube manometer. The actual water flow rate was determined by recording the time taken to collect the 3 liters volume of water at the tank. And the next one, the opening of outlet valve is being reduced for second reading of the experiment. The time taken has been recorded again to collect 3 liter volume of water at the tank for the actual water flow rate. And then the opening of outlet valve is being reduced, and step 4 until 5 were repeated for 5 different values of water flow rate. After finish, the manometer tubes have been removed first to avoid the bubbles in the tube, and then with pump in running condition, step 1 until 8 have been repeated for the other tested pipe section. After finish, all the manometer tubes from the system have been removed, the inlet and outlet valve were fully closed, and the pump and the main switch were being turned off.
Assalamualaikum. My name is Muhammad Shafiq and I will be presenting the results, discussion and conclusion. This is the table of data for sudden enlargement and sudden contraction pipes. This is the data for Y-type and T-type pipes. And this is the data for 90-degree angle, 90-degree bend and 45-degree bend pipes. Discussion. First, calculate the minor head loss and loss coefficient for each of the pipe components or fittings. For sudden enlargement, by doing minor calculation, we get the average minor head loss, which is 0.1467 meter. Loss coefficient is 0.4118 and average coefficient of friction is 0.0222. For sudden contraction, we get the average minor head loss, which is 0.0722 meter. Loss coefficient is 0.4118 and average coefficient of friction is 0.0262. For Y-type, we get the average minor head loss, which is 0.2665 meter. Loss coefficient 2.0 and average coefficient of friction is 0.0253. For T-type pipes, we get the average minor head loss 0.3452 meter. Loss coefficient is 2.0 and average coefficient of friction is 0.0236. For 90-degree angle, we get average minor head loss, which is 0.4579 meter. Average loss coefficient is 3.0. Average coefficient of friction is 0.0237. For 90-degree bend, we get the average minor head loss is 0.1926 meter. Loss coefficient is 1.4. Average coefficient of friction is 0.0257. For 45-degree angle, we get average minor head loss, which is 0.1221 meter. Loss coefficient is 0.8 and average coefficient of friction is 0.0237. This is the sample calculation to get the data. To find Q, we use V per T, B and C to find the velocity, D to find the kinematic viscosity. So later we use this to find the Reynolds number, E to get the F, and F to get the coefficient, loss coefficient KL, G to find the minor head loss. 2. Discuss the effect of different water flow rates, pipe diameters, and pipe bends on the value of loss coefficient. As the flow rate increases, the friction loss in the pipe also increasing. Smaller diameter of pipes, higher energy will be lost due to more friction. Longer the bend of the pipe, lower loss coefficient. 3. Discuss on factors contributing to errors or inaccuracy in experimental data and the possible recommendation to improve the existing results. Errors: presence of air bubble in the pipe system, net parallax errors when taking reading. The recommendations: ensure that there is no air bubble trap inside the pipe system, as the air bubble will block the flow rate of water. 2. Ensure that eye level was perpendicular to the scale. Repeat experiment at least 3 times to get the average data. Read carefully the lab manual before conducting the experiment. Conclusion: we were able to determine the loss coefficient and minor head loss in pipe components for different water flow rates, pipe diameters, and pipe bends. The flow in pipes is affected by minor head losses. To get a better result, some recommendations should be taken into the experiment. References: this is the references. Thank you.